So Paul has a starting salary of $42,000 and wow, he's going to get a 9% raise each year. He must work on Wall Street. How much will he make in the 20th year? Well, if he's making $42,000, one way to do it is we could say 42,000, and then if he's making a 9% raise, you could then say plus he makes 9% raise on 42,000. So that's what he's making the second year. And then you go, all right, so he's going to get that much money. So take that much money, 45,780. Now give him another 9% raise. So 9% raise on the 45,780. And so you could just keep doing this. Well, is there another way to do it? Another way to look at it is, this is like taking $42,000, putting it in the bank, getting 9% interest annually. So we could use the compound interest formula. So compound interest formula goes, the amount will be the principal, and then 1 plus the rate divided by n, and then nt. N is the number of times per year that you're paid interest, which is just going to be each year. That means n is 1 in this case. The starting amount would be 42,000. And then 1 plus the rate, 9% raise. Lucky guy. And then how much will he make the 20th year? Well, if you're going to be doing it this way, then you've got to be careful, because many people automatically say, oh, 20th year, t equals 20. But that's not true. Because if you look back over here, when we did it this way, we would have to do this 20 times. But notice, back here, the very first year, he made $42,000. He didn't make $45,000 his first year. He made $42,000 his first year. That means he only gets 19 raises. The first year, he didn't get a raise. So that means this is raised to the 19th. And then let's find out how much that is. So 42,000, 1.09 is raised to the 19th. So his 20th year, wow, he's going to be making $215,949 and 77 cents. So there's part A. Part B, how much would he make during the first 20 years on his job? So that means now figure out how much did he make the first year, the second year, the third year, fourth year, all the way up to this 20th year, and add up all 20 years. Well, this is definitely a pre-calculus problem. If we just did this formula 20 times in a row, wrote down all 20 numbers, and added them up, that's really more like a beginning algebra way to do it. We need a more advanced way to do it. Well, we could, instead of having to type in all those numbers, we could have the calculator do it. So what we would need is, to do this formula 20 times, having 0 at the beginning because you got a 0 raise the first year. And notice, if you have a 0 as the exponent, all of this becomes a 1. So you'd have 42,000 times 1, which is his first year's pay, all the way up to this 19th. So one way to write it is, we need the sum as n goes from 0 to 19 of 42,000 times 1.09 to the n. And then we could actually have the calculator do this. So you ask the calculator, do the sum of a sequence. It is 42,000 times 1.09 to the n. Actually, on the calculator, it's easier to use the letter X. Let me change that quickly. We'll use an X. And then you tell the calculator I'm using the variable X, which seems redundant, but when you're in third semester calculus, it won't seem so redundant. Anyway, have it start at 0 to 19. Okay, for sum, that is right here under list. So you go second list, move over to math, and it's the fifth one. To find sequence, you go back to list, second list, operations, and then number 5, sequence. Now, depending on the calculator you have, it may look like this. If it's a brand new calculator, which mine is and has the newest operating system. So you would just type in the expression right there, the variable is x, and then go from 0 to 19, steps of 1 year at a time. Since most people don't have that newest operating system, let me show you what it looks like on the older calculators. As you can see, this is an older calculator. So you go second list, that part's the same, sum. Second list, that part looks exactly the same, except now it's just going to be on the screen and you just type it like this. So 42,000 times 1.09 raised to the x, comma x, to tell the calculator that's our variable, from 0, comma 19, and then close 2 parentheses. So he's going to have made over 20 years 214,8725.03 when you round it. So he's over 20 years at this job, he will have made a little over $2 million. Now if you look at this, the 19th year he made over $200,000. So that means the 18th year he probably made about $200,000. Etc., etc. So if you add up $200,000 over a few years, then eventually it adds up to a pretty big amount.